Okay, question 8. We're looking at a sequence of patterns made from octagons and squares. In the first octagon there are 4 squares. In the second octagon there are 7, and in the third there are 10, and in the fourth there are 13. So the first one equals 4 squares. But then every time we add an octagon, so if we make that 1 O for octagon, not the number 10, we add 3 squares. And we can use this to help us out when we're going to answer the question here, because it says the sequence continues and we want to know how many squares will there be in the pattern that has 40 octagons. Well, we know that in the first one there will be 4 squares, so we know that we're going to have 1 multiplied by 4, and so that's 4 squares. So that means there's another 39 octagons. So those 39, we only have 3 squares for each of those. And if we do 39 times 3, that adds up to 117. And if we add these two numbers together, we get 121. And that's how many squares there will be in 40 octagons. Now, the next part of the question is asking us for the rule that connects Q and N, where Q is the number of squares, that's here, and N is the number of octagons. Okay, so if we think about it, really, each octagon has 3 squares, and then there's an extra 1. And we know this because if we look to the previous answer that we had that 40 octagons equals 120, and that's a little bit like 40 times 3 and then add 1. So 40 is the number of octagons, and it tells us here in this second part that we're going to use N. So this is like, N times 3, because we had to multiply each one by 3, and we added 1 to that, and then that told us how many squares there were. And it tells us in the question we want to use a letter Q to represent squares. So we can say that Q, the number of squares, equals, well, over here I've written N times 3, but we don't write that in algebra that way. We always write the number first. So it's going to be 3 lots of N plus the 1. If we think about it, we can understand this very, very easily. Let's just go back to the diagram that we had at the beginning. We'll move that out of the way. If we look closely and we actually zoom in on the diagrams, we can see that we have 1, 2, 3, 4 squares in the first one. And what's actually happened is that when we've added the extra octagon, we only needed to add these 3 squares. And the same when we added the next one, 1, 2, 3. So what we could actually think about if we go back to the first situation is that here are the 3 squares that we add each time, and here's a sort of extra one that we needed to start us off. And that helps us with the final rule that tells us, move this up here as well, that the number of squares is equal to 3n plus 1. And there you have it.